Okay. We're going to do some level 2 here. Basically, we're not actually writing a proof. What we're working on is finding the order of steps. Now think back to the law of syllogism. You all know this one, right?
Yeah.
Basically, it says, given A, right? If we give you A, we need you to prove E. Well, the way you would do that is by saying, well, you know what? A causes B. B causes C. C causes D. D causes E. Therefore. By the way, does anyone know how to say this?
No.
Therefore, A causes E. Okay? I want you to recognize that basically that is the underlying logic for proofs and actually for all geometric problems, although we don't always do them. So basically, we need to know what the given things are. What are the things that you could tell just from looking at the problem? So those things will always be the first things that we write. So what's a first thing that we can put?
AB.
AB equals 9? Does that make sense? Because that's right there in the problem, right? Okay, so we can call that 1.
And then AC equals 15.
AC equals 15? Okay. That can be 2.
And then AB squared plus BC squared.
That incorrect. By the way, what type of problem is this going to be, guys?
Pythagorean theorem.
Pythagorean theorem. What kind of triangle do you need for a Pythagorean theorem?
Right triangle.
So we need to state that it's a right triangle before we use the Pythagorean theorem.
ABC is a right triangle.
Triangle ABC is a right triangle. That works.
3, and then A squared plus B.
And then AB squared plus BC squared equals AC squared.
Could also be 1?
Can these three actually be in any order?
Yeah.
Yeah, they have. They none of them cause each other. They're all sort of prerequisites to get into this point. So if we didn't know these, we could not do this. It does not matter what order you write those in because they all are necessary before you get to that. And that happens a lot in proofs. Okay. And then, of course, the last one is always the last one. It's the answer.
6.
So.
Oh, 5.
Right? Okay. Let's try a different one. I'm not trying to do hard problems here. I'm trying to get you guys to work through the sequence. So let's do a different one.
Medium.
Medium?
Yeah.
Alright, I'll do something that you at least probably don't remember very well.
Figures. Knew you were gonna do that.
Okay, so this is the box. Now we need to put these things in sequence. You should be copying this, by the way. If you're not copying, you're letting yourself fall behind. go. So, it's like a syllogism. We got to figure out what starts it off in order to figure out how we get to our conclusion. So how many steps are here?
5.
5. Okay, the last one will always be the conclusion or the solution, the thing that you're trying to prove. So do you see this in your list?
The first one.
It's the top one. So what number will I put there?
5.
5. Why do I put 5 there?
This is the solution.
Because the solution is the last thing. It's the last of 5 steps. Okay. So now, things we can start with. Usually you start with things that are given. So what's given? So let's do this
BD.
right. Line, BC, parallel to line EG. Do we have that exactly written?
Yeah. BD parallel to
Does this mean
EG.
the same thing as this?
Yeah.
Yeah, it does, right, because BC and BD are the same thing. So what number should I put there?
1.
1. Does everybody understand that? This statement and this statement mean the same thing because line BC is the same thing as line BD. Okay. Next, do we need to say the measure of the angle? Do we need to state that they're corresponding angles or state that the corresponding angles are congruent?
Corresponding angles are congruent. Ah.
Why is
Cors-
that important if we don't know the measure of any angles?
Yeah, you do. You know.
We haven't said
Says,
it.
you know,
Think about it. The first thing you said, the first thing we know is these lines are parallel. That's fine. What else do we need
Oh,
to know next?
BCF is equal to 100 degrees.
Okay, so if we said that BCF, this angle is equal to 100 degrees, that's the next important thing to know. So basically, that's the thing that gets our 2. Because now that we know we have parallel lines, and we know the measure of this angle, that's getting us towards what we need to know, which is this one. So now that we know that the lines are parallel, and that this is 100 degrees, do we need to know that they are corresponding angles, or that corresponding angles are congruent?
Corresponding angles are congruent. Oh.
Isn't it more important to know? I mean, there's no point in saying this if we're not already talking about corresponding angles.
Point.
So we say that they are corresponding angles, and then you could say corresponding angles are congruent. Okay? So this becomes our 3,
and then 4.
there's our 4. So observe again what we're really saying. We're saying that line BD is parallel to line EG. We have parallel lines. Okay? Next we're saying that the measured angle BCF is 100 degrees. It's given right there in the drawing. So if we have parallel lines and we know this, we can start to prove some other things. Third, we say EFH, this one here, and BCF are corresponding angles. So we set them up as corresponding angles. Next, we say corresponding angles are congruent. Therefore, these ones, which are corresponding angles, must be congruent. That allows us to draw the conclusion the measured angle EFH has to also be 100 degrees. Okay? So the problem itself is extremely simple. A lot of you guys could look at it right away and just write 100 right there without doing hardly any thinking. But this is the logical sequence of events. So 1, 2, 3, 4, 5. Should we do one more level 2? No? Would everybody just like to do their assignments?
Yeah, we're good.
Sounds good to me.